Imagine the universe's history as a single year. The Big Bang is January 1st. The Milky Way forms in May. Earth and our solar system don't show up until September. Life appears weeks later, and dinosaurs rule for just a few days in late December, gone before New Year's Eve. Humanity, all of recorded history flashes by in the last seconds before midnight. Our industrial civilization, skyscrapers, space probes, fossil fuels, exists for only a blink of that final second. Yet we see our cities as eternal, our achievements as the pinnacle of Earth's story. But Earth is ancient, 4.5 billion years old, with chapters so old we can barely decipher them. This vastness of time raises a humbling question. Are we truly unique? Could another species millions of years ago have built cities, reached for the stars, and vanished, leaving almost no trace? This is the Silurian hypothesis, a scientific inquiry, not science fiction. If an industrial civilization existed 60 million years ago, what evidence would remain? How would we even begin to look? To answer, we must journey deep into Earth's past. We imagine our civilization's legacy as ruins, skyscrapers, pyramids, the Great Wall. But geologic time is relentless. Over millions of years, Earth's surface is recycled, eroded, and subducted into the mantle. A city abandoned for 60 million years wouldn't be a ruin. It would be gone. Even the most durable artifacts would be ground to dust or buried deep beneath new rock. Like writing in sand at the ocean's edge, time washes away all traces. The vast majority of Earth's ancient surface is lost, recycled, or eroded. Finding a fossilized artifact from a hypothetical ancient civilization is nearly impossible. So we must look for indirect evidence, subtle, global-scale changes left in the planet itself. Not fingerprints, but shadows, chemical echoes and geological whispers in the rock record. An industrial society leaves a global footprint, energy consumed, waste produced, that might just outlast everything else. That's where we must search for the ghost of a lost world. Our world is wrapped in plastic. Clothes, computers, packaging, cars. We produce hundreds of millions of tons each year. Plastics feel permanent, but over millions of years, sunlight, abrasion, and microbes break them down. Instead of fossilized bottles, only a thin layer of chemical residue, hydrocarbon molecules, would remain in ancient sediments. A future geologist might find a chemical anomaly, not a plastic bag. But nature also produces complex organic molecules, making it hard to distinguish industrial residue from natural decay after eons. Our plastic legacy, so obvious to us, would likely become just another faint chemical signal in the rock. The same would be true for any ancient civilization's unique materials. Perhaps they used different polymers, ones we wouldn't even recognize. We'd be searching for a chemical needle in a geological haystack with no idea what the needle looks like. The search for a lost civilization becomes a search for a chemical ghost. The challenge: would we even know what to look for? Our most enduring mark may be a subtle, nearly invisible chemical trace. That's the legacy of plastic in deep time. Our cities, concrete and steel, are our proudest achievements. We've made enough concrete to cover the Earth in a thin layer. If we vanish tomorrow, these structures might last centuries, maybe millennia, but concrete is just artificial rock. Rain, plants, and freeze-thaw cycles break it down. In thousands of years, buildings collapse to rubble. In millions, that rubble is ground down, washed away, and becomes new rock. After 60 million years, nothing recognizable as a city would remain. Yet the chemistry of the rock might be odd. Concrete leaves a unique mix of calcium and silicon. A future geologist might find a thin layer with unusual concentrations, a composition that doesn't match natural processes. The evidence wouldn't be a fossilized skyscraper, but a subtle geochemical anomaly. It would be a puzzle, a line on a graph that doesn't fit. Was it a volcano, a strange ocean event, or the dissolved ghost of 1 billion tons of artificial stone. The clues would be faint, but they might still whisper of a lost city. That's the challenge of finding industry in deep time. Our civilization runs on metal, iron, aluminum, copper, rare earths, refined and shaped into the skeleton of our world. Pure metals are rare in nature and clear signs of technology, but most are unstable and corrode back to minerals. A car left outside becomes rust in decades. In millions of years, even buried steel beams dissolve, their atoms dispersing. Sometimes minerals replace decaying objects, creating perfect casts, fossilized wrenches or circuit boards. But the odds of finding one are astronomically small. More likely, we'd find chemical signals. Global mining and refining concentrate metals in ways nature rarely does. Industrial runoff changes metal concentrations in rivers and sediments. A hypothetical ancient civilization would have left similar traces, layers with high copper, zinc, or rare elements. The metal bones would be gone, but their chemical signature might remain. Future scientists might puzzle over a spike in platinum or iridium, wondering what caused it. The real legacy of industry is not the artifact, but the altered chemistry of the planet. That's the ghost metal leaves behind. In the end, it's the chemistry, not the object, that endures. That's what we'd have to find. If cities, plastics, and metals vanish, how do we hunt for a lost civilization? We become geological detectives. Our clues are buried in rock layers, Earth's history book. Geologists drill deep, extracting sediment cores. Each layer tells a story of climate, life, and chemistry. We're looking for anomalies, a chapter that doesn't fit. Industrial civilization disrupts natural cycles, especially through burning fossil fuels. This releases carbon with a distinct isotopic signature, lighter than volcanic or oceanic carbon. The change is recorded in marine shells, then in limestone on the ocean floor. A sudden spike of light carbon in a sedimentary layer would be a key clue. Scientists have found such events, like the Paleocene-Eocene thermal maximum, or PETM, 56 million years ago. Isotopes, different flavors of the elements, are powerful tools for tracing the past. Burning fossil fuels changes the ratio of carbon isotopes, leaving a clear industrial clue. The PETM saw a massive release of light carbon, but was it volcanoes or something else? The record is blurry. Nitrogen isotopes offer another clue. Our artificial fertilizers, made by the Haber-Bosch process, have changed the planet's nitrogen cycle. This industrial nitrogen has a unique isotopic signature, now making its way into sediments. Finding a similar shift in ancient rocks would suggest industrial-scale agriculture, evidence of a large, sophisticated society. We'd be seeing the chemical echo of ancient farms. Heavy elements tell stories too. Industrial processes and nuclear technology create radioactive isotopes, not found in nature. Some decay quickly, but their products could linger. Discovering rare elements like curium or americium in ancient rocks would be almost impossible to explain naturally. A smoking gun for lost industry. Isotopes are the fingerprints of civilization in deep time. Industry doesn't just change chemistry, it changes climate. Our carbon dioxide emissions trap heat, raising global temperatures. This rapid warming leaves a clear signal in the geological record, visible in oxygen isotopes from ancient ocean shells. The PTM is a prime example. Global temperatures soared, oceans acidified, and mass extinctions followed. The cause is debated: volcanoes, methane, or something else. But the event's profile looks eerily like our own path. Could the PTM have been the Anthropocene of a lost civilization? It's a tantalizing possibility. To prove it, we'd need all the evidence: carbon, nitrogen, metals, synthetic chemicals, converging in one layer. Only then could we tell the story of a planet's last industrial fever. The Silurian hypothesis asks, Are we truly the first industrial civilization? Given hundreds of millions of years of complex life, it's plausible we're not. If a civilization existed deep in the past, direct evidence would be gone. Only subtle geochemical signals would remain. The name comes from Doctor Who, but the idea is serious science. It challenges our assumptions about recognizing predecessors. We might already be looking at the evidence, like the PETM, and misreading it as natural. The conditions for industry, complex life, intelligence, hands, have existed for a long time. Dinosaurs ruled for 150 million years. What if, somewhere, a clever species took a different path? The hypothesis is also a mirror. The signals we look for in the past are the ones we're leaving now. Our legacy may be a geological scar, a story for future civilizations to decipher. Did ancient civilizations leave hidden traces? We don't know. We haven't found a definitive package of evidence, just ambiguous clues like the PETM. But asking the question is important. It humbles us, shattering the idea that we're the universe's endpoint. Industrial intelligence might be a recurring planetary phase, ending in collapse and leaving only a chemical scar. This connects us to deep history and to the challenges we face today. Our legacy may be a fleeting fever spike, or, if we're wise, a long, enduring presence. The story isn't written yet. What mark will we leave in the rock record of time?